Okay, so I ran out of time on the last video. Go ahead and do exercise 31 if you would in the book. I'll pause and we'll come back in just a second. Excellent. All right, fourth video, let's talk about end behavior models. An end behavior model says what I want to do is I want to know what happens to a function way out on the edges. X is huge. Absolute x in either direction doesn't really matter. It's a huge value of x. Now, what happens in the middle on an end behavior model? Completely irrelevant. So if I look at the following two functions, f of x, g of x, 3x to the fourth, looks something like this. A little wobbly, but not really. This is g of x. What does f of x look like? Well, f of x is going to look the same out here, large values of x. It's going to look the same out here, large negative x, or very small x, depending on how you want to look at it. But this is going to like just wiggle all over the place in here. I don't really care. The question is, what does it do here and here? And that is an end behavior model. And we can tell that they are going to do the same things because when x gets large enough, 2x cubed is much, much less than 3x to the fourth for large x. Ditto 3x squared and 5x and 6. Large enough x, those become insignificant, and what we then have is something that on the ends looks like 3x to the fourth. So let's take a quick look at well, why don't you guys do exercise 31? Excuse me, you already did 31. Why don't you do exercise 39? Pause the video, come back in a minute. Okay, sounds good. So let's do a definition. How do we define an end behavior model? We define an end behavior model if f of x over g of x approaches 1. The limit as x goes to infinity, f of x over g of x equals 1. So if you look back at the previous functions, we've got f of x was 3x to the fourth minus a bunch of smaller stuff. G of x was just plain old 3x to the fourth. This stuff becomes insignificant, and we're left with a 1. Now, positive infinity, this is actually called a right end behavior model. And you can probably guess that a left end behavior model is the limit as x goes to negative infinity of f of x over g of x is equal to 1. Notice that it's never equal to negative 1. It's always equal to positive 1 because what we're looking at is, do they do the same thing? Not just one go up and one go down. Well, then that's not an end behavior model. They both go up, and if the ratio is equal to 1, then that's an end behavior model. Okay, let's do another quick example here. This is example 7. And we're on page 74, and f of x equals complicated long function 2x to the fifth plus x to the fourth minus x squared plus 1 divided by 3x squared minus 5x plus 7. And what we need for an end behavior model is g of x. We need something that the end behavior model will give us the limit as x goes to infinity. Going to quickly switch videos, so come back.